Hello viewers, welcome to my channel. In last video, you learned image formation and ray diagram in concave mirror. Now today I am going to discuss image formation like concave mirror and convex mirror also form an image. So let's start using two basic rays. Okay. So in concave mirror, you know that one ray is passing through the center of curvature denoted by C, right? And one ray is parallel to principal axis. Okay. By using these two rays, we are going to form the image. Okay. In convex mirror also. So let's start now. This is your convex mirror, right? This is your principal axis, this is your pole P, okay, P point, and this is your center of curvature. Now a ray is incident ray is passing through the center of curvature C, right? So it is looking like that. So it's reflect in same direction, because if you take a normal which is passing through the C, so angle of incidence and angle of reflection both are same, right? Almost zero, right? So the incidence ray and reflected ray are always in same direction, right? So it's reflect in same direction. Likewise, another ray which parallel to principal axis, so this is your convex mirror, this is principal axis, this is your pole P, focus point F, and C, right, center of curvature. Now a ray is parallel to principal axis, okay. So we take a normal, okay, and it is reflect like this. So your focus point is here, right, inside the mirror, right? Is that clear? So a ray passing through the center of curvature and a ray parallel to principal axis are basic ray which we used in image formation. So first image formation. So first image formation is an object at infinite distance. So this is your convex mirror, right? This is your principal axis, right? This is pole P point, okay, F, okay, and C. Now this is the incident rays which coming from the object which at infinite distance, so that's why it is parallel to principal axis. Now your reflected rays is like this, okay. So if you see from this point, okay, you take your eye here and you see, then it's come from the you can see that inside the point of the mirror, right? So that point is focus point. And a convex mirror is also called a diverging mirror. Why? Because rays are diverted, okay. On the other hand, concave mirror is also called a converging mirror. Why? Because all the rays are converge at one point, which is focus point, okay. And here all the points are diverging, right? So now what is the position of object at the infinity, right? Position of image is behind the mirror. So you form image here, right? Here your two rays will be made. So it is focus point. Size of the image is highly diminished, okay, it is very small, and it is behind the mirror, so that's why it is virtual and erected. So it's above some principal axis, right? And it is virtual because it is behind the mirror. Remember these things. All the image are formed by the convex mirror are always virtual, right? Let's take one example. So this is your convex mirror, principal axis, pole, P, point F and C. Now your object is between C and P, okay, anywhere it is between infinity to P, right? Here only two cases are there. Your object is either at infinity or it is between infinity and your pole P, right? So it's between anywhere. It is beyond the C, it is at C, it is between C and F, okay, it is at F, or it's between F and P. For any object, the formation is same, okay. So that's why I told you that the convex mirror is easier than concave mirror, right? Because concave mirror have many possibilities, but in convex mirror only two possibilities. One object is at infinity and second one is it between infinity and pole P. So now let's take a rays. So one rays is parallel to principal axis, okay, so it's diverged, okay. Another is passing through the C, right? So here this is diverging, so that's why we take a one ray in from the focus point, so like this, okay. So here your point is met, right? So your first point is here of the image, so here your image will be formed. So now you can easily see that the image is behind the mirror, okay. So that's why this image is also virtual, right? So in convex mirror all the images produced by the convex mirror are always virtual. So position of image is between infinity and P, right? Position of image is between P and F behind the mirror, right? Size of the image is diminished, you can see that, and nature of image is virtual and erected, you can see that, okay. So this is the table which you can see, okay. These are the two possibilities of the position of the object, okay, and all the images which form like this, okay. Now next is mirror formula. Before start the mirror formula, okay, sign convention for reflection by spherical mirror. So let's start. This is your spherical mirror, this is an example of concave mirror, right? This is your pole P. Now this is your Cartesian plane, okay, and here your pole P, okay. What is the coordinate of pole P? It is 0 0, right? And your principal axis is x-axis, right? This is called as a x-axis, right? And above the P, this is your positive y-axis and this is your negative y-axis. So you know that what is the sign from right side, left side, top and bottom. So let's start with this. So in right side all the numbers are positive, which you know in Cartesian plane, right? So this is also called a new Cartesian sign convention, okay. This is also called new Cartesian sign convention. So all the digits are from right side of the pole point P is in x-axis are positive, right? Left side is all are negative, right? Above P it is a positive, right? And down from P is negative. So this is look like a Cartesian plane, okay, which you know already, which is this is your x-axis, this is you consider as a y-axis, right? So all the numbers which right side is always positive, okay, from 0 0, and all the left side are negative, that's you know very well, okay. So now we start mirror formula. So this is your concave mirror, right? This is your principal axis, this is pole P, center of curvature, right? Focus point F. This is your object, okay. Now I take a parallel ray, Okay. Next, a ray passing through the sea, and this is your image, right? This is beyond the sea. This is the case of beyond the sea, right, of concave mirror. Now let's take some variable. A distance from P to your object is considered as a U, right? A distance between F and P is considered as a F, which is called as a focal point, right? Focal length, sorry. And a length from P to object is called V, right? The height of the object is H and height of the image is H dash. So the distance between P and image is V, okay? P and F is F and object and P is U, right? So this is a variable. Now you consider that here these two triangle are formed, right? Now these two angles are opposite angles, so that's why it's both are same, okay? You know that this is a 90 degree, right? Clear? So by similarities, you can say that these two triangles are similar, right? So if these two triangles are similar, then the ratio of this triangle sides of this all the triangle are same. So let's take a ratio. H and H dash is equal to F upon V minus F, because H is here, right? H dash is this, so this side is upon this side, right? And this side is F, right? And this is considered as a V minus F because we consider this distance only, that's why, right? So let's take one for this. Now there are another two triangles. You can see that like this. Here these two triangles are there, right? Similarly these two angles are same. This two triangle is 90 degree. So by a similarity these two triangles are also similar, right? Now if these two triangles are similar, then the ratio of this side of this triangle are also same. So H upon H dash is equal to U minus 2F, because U minus 2F, because distance between P and F is F and P and C is 2F. It is almost double than F focal length, right? So U minus 2F. So consider this, and this is 2F minus V, because this from P to C it is 2F, and if you minus V from 2F, then you got this distance, right? So let's take 2. Okay, now this is your first equation, this is your second equation, which is H dash upon H dash, and here also H dash upon H dash. So from 1 and 2, these two terms are equal, right? Now let's cross multiply it. Okay, this is nothing but cross multiplication. Now multiply the term. So F inside the bracket 2F square, okay, FV. Likewise UV, UF, 2FV and 2F square, okay. Now here you know that 2F square and here also 2F square, so 2F square both are cancelled. Likewise here 2FV and here are 1FV, so 1FV is cancelled, right? So here 0 is remaining and UV minus UF, okay, and 1FV, right? Rearrange them, okay. Take a U common. I take U from this common, right? Now interchange the term. U is come to the denominator and FV come to the denominator, right? Now V upon FV, so VV get cancelled, so 1 upon F minus F upon FV, so FF get cancelled, so 1 upon V, so it's give you 1 upon F minus 1 upon V, right? Now by convention you know that these all are in minus, right? So we rearrange them, right? But all u, v and f all are minus because this is left side of the pole, right? So it is minus. But all the three term are minus, then it's give you again plus. So that is no use, right? Like this. So this is your final mirror formula. Okay. So what is the application of mirror formula? It is nothing but a mathematical representation of your mirror, right? So what is the distance of image and how you can easily calculate your image distance focal length, okay? Distance from the object, distance of the image, okay? You can easily calculate them. Thank you.